Here is an explanation for the answer to final exam question number 51 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 428. We're talking about a weak signal radio frequency amplifier and what its sensitivity depends on. And then we're given 5 choices. Well, the correct choice, the long and the short answer here, is that the correct choice is B, the gain and the noise figure. Now the gain, this is a schematic diagram, by the way, of a weak signal radio frequency amplifier like you might find as a preamplifier in a radio receiver, wireless radio shortwave receiver, for example. This device right here is a junction field effect transistor, which works very well in this application. It happens to be an N-channel device, and you can tell that because of the arrow that points inward at the gate. The signal goes from the antenna into the gate with a tuned circuit right here that can be used to provide a certain measure of selectivity so that unwanted frequencies will be attenuated to a certain extent. And there's another tuned circuit right here tuned to the same frequency. The primary of the output transformer, along with that 200 picofarad capacitor, tunes the circuit. That 200 picofarads is the maximum value of a variable capacitor in each case. This circuit is described, or rather presented, and shown in figure 7-11 on page 226, where weak signal amplifiers are discussed, page 225 and 226. 225 and 226. You'll find a discussion of those devices. If you happen to have the electronic version and don't have the printed book with page numbers, you'll find this under the header RF amplification in chapter 7. And again, this is figure 7-11. This is a very good example of a weak signal amplifier. The gain and the noise figure are the primary considerations in a weak signal amplifier when we want to talk about its sensitivity. The sensitivity is the signal to noise ratio, basically the number of microvolts necessary at the antenna to get a certain signal to noise ratio. So we need to have, say, maybe a couple of tenths of a microvolt at this antenna might provide a signal to noise ratio at the output of this device of something on the order of 10 decibels. The specifications of sensitivity are given in standard form like that, and the lower the number of microvolts, the better. Well, the amount of gain produced by this device right here, and also the amount of internal noise, affect the sensitivity of the entire amplifier and ultimately the sensitivity of the entire receiver if this is the preamplifier or so-called front end. This is a good example of the front end amplifier in a radio receiver for shortwave in particular. Well, so the noise figure is a measure of how much noise the device here actually introduces into the circuit. All devices like this produce a certain amount of noise, and we want that noise to be minimal, and a JFET, junction field effect transistor, is a really good device in the sense that it doesn't generate very much of that noise, and it can also provide a good deal of gain. So the things that really matter here are the gain and the noise figure. Those are the important considerations, and again, the correct answer is B.